Hello and welcome back Math 30-2. Today we are learning how to apply sinusoidal functions to actual word problems or real life situations. Now when do we use the sinusoidal function? Well, sinusoidal functions involves a period, like we're looking at sine, which is a circle, or cosine, which makes a trig circle. So anytime we have a period or some things that overlap each other, revolutions, things that move in circular motions, that will be a sinusoidal function. And we use those to help us solve the problems. So here we go. Here's my first example here. It says a nail is caught in the tread of a rotating tire and at point N. Okay? And it goes all the way up and down, up and down, up and down. So there's the top of the tire, bottom of the tire. Okay? So the points A and C are the max and min. That makes sense. This is the top of the tire, bottom of the tire when it hits the ground. And we also know points N, B, and D lie on the midline. Well, the midline goes straight across like that. And that's the middle. That's where the axle of the tire is right here. Over here, like an axle. Okay? Now, next part here says the diameter of the tire is 50 centimeters. So the diameter is the whole distance from the center out. This is 50 centimeters. Okay? So the diameter is 50 centimeters. So from here to the bottom is going to be 50 centimeters. Now the tire rotates at 10 revolutions per minute. Well, remember from before, revolutions, that's all the way around a circle. So all the way around the circle is one period, right? Like sine wave. So 10 revolutions per minute. That's interesting. So that means there's 10 periods in a minute. Next one says, after 1.5 seconds, the nail reaches its maximum height. A is the maximum height. That's after 1.5 seconds. Then it says, after 4.5 seconds, the nail touches the ground. It's here. So after 4.5 seconds, the nail will touch the ground. So now let's take a look at Jake's method. Jake's used the information to write the scale of each axis. Okay, so first he did, why did he mark 4.5 at point C? Well, so point C is 4.5. Because after 4.5 seconds, the nail touches the ground. That's simple. And when it touches the ground, that's our minimum. Next part says, write the numbers at the scale mark of each axis. Okay, so that's 4.5. My max is right here, 1.5. So the middle in between, well, must be in between those, looks like we're counting by 1.5s, it's going to be 3, right? Oh, D, that's going to have to be 6, because we found out we're counting by 1.5. These are seconds, 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 seconds. Okay? Now, mark the scale of each axis. Well, this here is going to have to be 50, because that's the diameter. The diameter is 50, so from top to bottom of the tire is 50 centimeters. Okay? Now it says determine the amplitude, period, midline of the graph. Okay, so amplitude, period, midline. Amplitude is equal to max minus min divided by 2. Well, my max is 50. My min is 0. It's on the ground. It's 0 centimeters from the ground. Divided by 2, which will give me 25. Okay? What did we want? There's amplitude. Period. Okay? Period is equal to, well, from here to here is one full revolution, right? 6 seconds. Or I could have kept on going. This would be 7.5, 1.5 to 7.5, 6 seconds. Or I could have thought of it this way. Let's see. I have 10 rotations, 10 periods in a minute, 60 seconds in a minute. 60 divided by 10, 6 seconds a period. So it's 6 seconds. And then my last one is my midline. Well, midline is my D value is equal to max plus min divided by 2, which is 50 plus 0 divided by 2, which is equal to 25 centimeters. Okay? Now it says determine the equation for the height of the nail as a function. Okay. We're just using it this way. Nice. No, what is that called? No phase shift, so we're good. So my A is 25. sine my period. Oh, we have to find b. We know that's b. So b is equal to 2 pi divided by whatever my period is. So my period is 25. Okay? If we have it in terms of pi. If I had it in terms of degrees, it would be 360 divided by 25. But I'm going to keep it in terms of pi. So I have 2 pi over 25. Okay? So that's my b value. So I have 2 pi all over 25. Oh, sorry, my period is 6. 2 pi over 6. Or else I could have gone 360 over 6. I don't know what I was thinking. 2 pi over 6, which is the same as pi over 3. So I should place that with pi over 3. Okay? Now, what do I want to do? We also need to add d, which is 25, plus 25, because that's my midline. Oh, it wants it in terms of h of t. And this is t as in time. Okay? So, how far to the nearest 0.1 centimeters is the nail above the ground after 6.5 seconds? So to do this here now, I have to use my graphing calculator. So I plug everything into my graphing calculator. Y equals, just make sure my mode is in radians. Yep. Clear. So we have 25 sine, here's my sine, sine, and second pi divided by 3, bracket, plus 25, and my window, well, ooh, someone was really big here. So my max is going to be, I'm going to say 60, my min, negative 60, negative 10, because we don't really go below, I'm going to say 60, just so I can see it. I have a bit above and below. My x, I'm going to say is going to be, no, not even. I'm going to say 12. I want to see 2 periods. So I graph it. Oh. X max, 0, 10, 12, 60. Huh. Let's see. X scale is 1. Let's see, what did I do here? Ah, that's why. I forgot my x. And I put in my x. There we go. I had a straight line. Something wasn't right. So I put in my x. And there we go. Now, I want to trace for when it is at, which value here? Nearest 0.1, 6.5 seconds. So trace 6.5, enter, I get 37.5. So it's 37.5 centimeters. 37.5 centimeters above the ground. Okay? That's it. Next question. So here is Gilles' method. So Gilles completed this table. Okay? So Gilles decided that he could use data points in ABC to perform a sinusoidal regression. So he made the table and put all of these in the table. So we're going to use these points here. And he looked at these and put them into the table. So he had 1.5 is 50. So 0 is 25. 1.5 is 50. Okay? Then he said 3 is at 25. Then he said C is 4.5 is 0. And D is, what was it again? 6 is 25, because we're back up. So he put those in his calculator. And went into the stat function, edit, clear, clear. I just have to clear mine. So I have 0, enter, 1.5, enter, 3, 4.5, and 6. And to the side we have 25, 50, 25, 0, 25. Oh, now we're going to go stat. We're going to go over calculate. And what kind of regression do we want? A sinusoidal regression, sine regression. And there we go. That's how he found the formula. A 25, B is that. So that's how he found the formula there. Now, complete the table, perform. So he saw it as, if we fill this out, 25, HT is equal to 25, and he has sine 1.04 or 1.05 x and no c, and he says plus 25. Okay, there is no c. How he did that. Okay, now how far to the nearest tenth is after 6 seconds? So for this one, okay, so clear, and I have to put in my statistics regression. Oops. Equation, regression, enter. So I graph. It goes like that. And he wants after 6.5 seconds. So trace 6.5, and he gets 37.5, same thing. So those are two ways of doing it. I prefer the other way, but you can also do it this way here. Now the last question before we are done. It says, the depth D in meters of water in the harbor after so many times. So we're looking at the harbor. Now, that has to go with the rotation of the Earth and everything. So once again, sinusoidal function. It goes up and then down, depending on the time of the day. Up and then down, up and then down, right? So the depth of the water, think of tides. Once again, that is a period, up and then down. There's a period in there. So that's why it's a sinusoidal function. State the amplitude of the equation, the midline, and hence determine the maximum and minimum. So what is my amplitude of this function here? Okay, well I look at this, it's kind of written in a weird way, isn't it? I have 12 plus. I would like to rewrite this as y is equal to 5 sine 0.24 t plus 1.57, and then we have plus 12. That looks better. So this is my D, this is my A. So it says the amplitude of the equation, A is equal to 5. Okay? The midline is 12. D is equal to 12. So that's Y is equal to 12. Now, what do we want to do? The maximum minimum? So that's going to be 12 plus 5 divided by 2. Oops. The maximum is 12 plus 5, which is equal to 17 is my max. And 12 minus 5, which is equal to 7, is my min. Okay? So that's the depth. Now, next part is determine the period of the function. Okay? So these here determine my up and down. Oops, sorry. This here and this determine my up and down. Now, for my period, that has to do with this 0.52. But that's my B. So period is equal to 2 pi divided by B. My B is 0.25 or 0.524. So I put down my calculator. And I end up getting 12. To the nearest tenth of an hour. Okay, 12 equals 12 hours. Okay, so every 12 hours. That makes sense. Every 12 hours, it's 5. Okay. So, write a suitable window that can be displayed. Write a suitable window that can be displayed. So, I look at this here. My max, that and that. So my max is 12, min is 7. So I'm going to say 0, or we're going to say, let's say 5 for my x, 5, 20, and count by maybe ones. Doesn't matter, it's only 15. And on my y value, well, my period is 12 hours. So I'm going to say, I'm going to look at two different periods. So I'm going to go from 0, because we're going to start at 0 time, and I want my max to be 24, so I can say 2 periods, and I'm going to count maybe by, I'm going to divide this by 4, so count by 3s. Okay? Next part here says, use the graph to determine the function and to the nearest tenth the depth of the water at 2 p.m. So at 2 p.m. Okay, so this is midnight. 2 p.m. is how far away from midnight? Well, it's 12 hours, and then another 2, 14 hours. So we want to know 14 hours. So 14 is my t. So I'm going to trace at 14. So let's graph this here. And I have, my formula is 12 plus 5 sine, make sure you can see that, sine, I'm just going to move this over a bit, light's coming in, 5 sine 0.524 t, or x in this case, and then we go plus 1.75, oops, 571, bracket, and then that's it. So I graph that. Oh, I have to change my window. Window. Okay, window. What did I say? I want between my y, it should be 20, and I'll say 5. This is 24, because I'm going to see 2 periods, and I'm going to say we're going to count by 3s. There we go. Look at that graph right there. Nice graph, looks good, everything's great. Okay, so then it says at 2 p.m., so that's after 14 hours. Okay, so 2 p.m., t is 14. So I just put trace 14. So trace, and we want 14. Enter. I get 14.5 meters. So the height after 14 is 14.5. So now the ship requires a minimum of 8.5 meters in its harbor at midnight. By what time to the nearest 10 minutes must it leave to prevent grounding? Okay, so at midnight. So what time must it leave? So remember, that's midnight there. So what time must it leave? Okay, so let's go. It has to be at least 8.5. So we go 8.5, graph. So it must leave before this time right there, that intercept. So I'm going to go second, calculate, and find my intercept. Because it's good, everything above. So we want first curve. It's going to take a while to get there. Push enter, second curve, guess. I get 8.5. We have in 4, so he has to leave at 4:50. 4 hours, 10 minutes. Okay. So he has to leave at 4.5 hours. Okay? So before that, so 4.45, so the ship requires 8.5 meters mar, but what time to the nearest 10 minutes? Okay? So I'm going to go 4 and 5, 4 hours, so that's at 4. Now we have to find minutes, so we go 0.47 times 60, because there's 60 minutes, so I'm going to go 0.477 times 60. So that is 28.6, so 30 minutes. Leave to prevent grounding, 20 minutes. So I'm going to say and 20 minutes, because it has to leave before then. Okay? So at 4:20 a.m. That's my answer. So what is the next time to the nearest 10 minutes that the ship can safely return now? Oh, so we go back to my graph. When can it return? Well, that it can safely return here. So we go second, calculate, I want my intersect. It could return somewhere in here. Up, enter, enter, enter. Now this one is 7.51. So in 7.51, so that's 7 hours, and I'm going to go 0.51 multiplied by 60. So I get 30.6. Now that 0.6 I have to round up because I have to be safe, right, to the nearest 10. So this time we're rounding up. So that is 7:40 a.m. See how that makes? Because it's 7.51 hours, which is 7:40 a.m. I had to round up because we have to make sure we can make it. I hope you understand this. Thank you for paying attention, and see you tomorrow.